A very good morning, children. So this video is on chapter number 2, atmosphere, part number 4. You can refer to your textbook from page number 20 to 22 for class 7 geography. So last time I was doing troposphere and I was explaining you about troposphere, okay, and I told you that, okay, the temperature in the troposphere decreases with height. In order to understand that, okay, we are going to look at this figure. Now you can see the diagram here. I have made a man here, mountain here, and air molecules. So I'm writing air molecules, okay, here. You can see this is land. So this land is basically our earth. So the lowest layer above the earth is troposphere. So I have written troposphere here, okay, and you can see both land and water is there. So I want to explain you why the temperature decreases with height in the troposphere. So let's learn through this diagram. So I have basically put a person here. So as you go far away from the earth to the upper limits of the troposphere. So to the upper limits of the troposphere means the upper limit of the troposphere is known as tropopause. So the upper limit of the troposphere is known as tropopause, okay. So when you are climbing, okay, away from the surface of the earth, or when you go far away from the earth, what happens? The temperature decreases with height. Okay, so why the temperature decreases with height? The number one point is, okay, now you have to understand, is due to gravity. Okay, gravity basically keeps the air molecules together. Now last time only I told you that in the troposphere that you find all weather conditions happening, as well as all the gases are present in the troposphere, and they are basically bound together, or okay, bind together by the gravity. Therefore you find this troposphere the densest layer and it is the closest layer, and therefore you find temperature also increases with height. So as you move away from the earth, what happens if you climb on top of a mountain? It makes sense also. Like when you climb a mountain or a hill, you find the air is thin, you feel some kind of difficulty in breathing, as well as the weather condition is also cold. The weather condition is also cold. Due to what? Because you are moving away from the earth and there is less gravity away from the earth. This is one of the reasons. So as you move away from the earth, the gravity plays a vital part, okay, in basically decreasing the temperature as well as the air pressure. Okay, so here, as you move away, what happens is you find low pressure here. You find, okay, air also becomes thin here, because as you move away from the earth, okay, the air becomes thinner and thinner, okay, and the temperature also decreases when you reach a certain height, okay, in the mountains. So as you go away from the earth, you find the temperature also decreases, but on the flat land you find the temperature is more, and this is due to what? Due to gravity. And you can see here I have written land and sea. This is called the sea level. This is called the sea level. At the sea level, you have, okay, 1013 millibars of air pressure. So the pressure of the air is also more here. So you find more air pressure here. Okay. So high air pressure, okay, high temperature, and okay, then you find air is also dense. Air is also dense because all the molecules of the air are bound together by gravity. Okay, so but one thing I want to tell you, why the temperature decreases with height. So I have shown you a graph last time. This side of the graph represents altitude and this side represents temperature. Now, if I basically put this line like this way, This line shows a negative relationship or an inverse relationship. With an increase in height, there is a decrease in temperature. So this is a negative relationship, which is also known as inverse relationship. Okay? Inverse relationship. Okay? So this is the graph of decrease in temperature. Now if I make another graph here, okay, and make altitude here and temperature here, but the graph points like this way. So with an increase in height, there is an increase in temperature also. This represents the positive relationship of a particular layer. This is also called positive relationship. So whenever I am talking about altitude and temperature, okay, in troposphere as well as, okay, in the mesosphere is one of the coldest layer. Temperature decreases with height. In the troposphere, it decreases due to the gravity, as well as you move away from the earth, the radiated heat of the earth, or the earth's heat basically, okay, is becoming lesser and lesser as you climb away to the mountains. And this radiated heat is basically called Earth's terrestrial heat, which is absorbed during the day, and during the night it has to basically evaporate in the atmosphere. But due to carbon dioxide and due to gravity, the heat basically stays near the surface of the earth. And as you move away from the earth, this temperature or the heat also decreases. Are you understanding? So, but what about pressure? Now pressure basically varies from place to place due to height. Okay, you find dense means what? D-E-N-S-E. Dense means thick air, okay, near the surface of the earth. You find many gases near the surface of the earth, okay, and the pressure of the air also, okay, is high near the surface of the earth. So I have written here 1013 millibars. But if you climb a mountain and reach the top of the mountain or the peak of the mountain, you find the pressure will be decreased to 800 millibars or 900 millibars, because as you move away from the earth, the pressure also decreases. Okay, this is the reason when we climb mountain, pressure decreases with height, and therefore we find low pressure. Okay, we find low pressure there, low temperature, as well as less air. Okay, therefore we find breathing problems. Therefore we wear a mask or a oxygen mask to, okay, when we are moving on to the mountains. When we climb the mountains, we wear, okay, oxygen masks, etc. Why we wear oxygen masks? Because the air is thin there. The temperature is also very low there. So it is cold there, as well as there is low pressure. This is the reason why, okay, we wear that mask. Okay, now we are moving on to another layer that is called, okay, stratosphere. Another layer that is called stratosphere. Now I am making a layer here. Now this is T-R-O-P-O-S, S-P-H-E-R-E, troposphere. Okay, and this is the initial layer or the boundary where you find tropopause, P-A-U-S-E, pause. From the tropopause starts the stratosphere, and it ends in the S-T-R-A-T-O-S, stratopause. Okay, stratopause, P-A-U-S-E, pause. Now we are studying about S-T-R-A-T-O-S, stratosphere. Now stratosphere basically starts from 18 to 50 kilometers. Okay, it starts from tropopause of the troposphere and ends in the stratopause. Okay, so when we are looking at this stratosphere, okay, the upper limit is called stratopause, the lower limit is called tropopause. Okay, and it starts from 18 to 50 kilometers. And one of the most important features of the stratosphere is that it contains ozone layer. It contains ozone. Okay, ozone layer. Okay, so it contains ozone layer. So there is a maximum, okay, or rich concentration of ozone. Ozone is a vital gas, okay, which is found from 20 to 30 kilometers. Okay, now the stratosphere starts from 18 kilometers to 50 kilometers. From 20 kilometers to 30 kilometers, you find ozone. Okay, and this region is basically known as ozonosphere. This region is basically known as ozonosphere. This region I am talking about, not this region. Okay, so what is the ozone? Now, ozone is a gas, a vital gas. Okay, when oxygen, okay, atoms combine, they form a molecule called ozone. So ozone means, okay, O3. Okay, it is made up of 3 oxygens. Okay, now ozone is vital for our survival as it absorbs, okay, harmful ultraviolet rays. Now I am writing ozone here. Okay, so O3. So number 2 is it absorbs harmful ultraviolet rays, okay, which is emitted or given by the sun. This causes temperature of this layer to rise. This causes the temperature of this region to rise. Therefore, you find, okay, in this ozone layer, in this stratosphere, you find with the increase in altitude, altitude, okay, there is an increase in temperature. So this is the graph. Okay, so this is a positive relationship. With an increase in altitude, you find the temperature also increases. This is known as, okay, stratosphere. So the stratosphere, the temperature increases with height in the stratosphere. Okay, now you find this increases due to the absorption of harmful ultraviolet rays from the sun, which heats or warms this layer. Now, another point that we have to understand is we are, okay, hearing depletion of ozone layer or shrinking of ozone layer is due to pollution. So, due to pollution, number 3 point, we find depletion, okay, or, okay, what we call breaking of ozone layer or shrinking of ozone due to pollution. Now, pollution is one of the major cause for which is harming our ozone layer, okay, which protects our earth from the harmful ultraviolet rays of the sun. And if this ozone was not present, okay, there, then what will happen? We'll have skin problems, okay, organ problems, etc., cataract problems, etc., eye problems, etc. So, due to pollution or excessive use of harmful chemicals like CFC gases, these are known as, okay, CHLOROFLUORO, fluorocarbons. These are known as chlorofluorocarbons. Now, these are found in aerosol cans, okay, aerosol cans. So, chlorofluorocarbons are found in aerosols and, okay, refrigerants. So, old refrigerators, etc., basically emits chlorophorus carbon. Okay, when emitted in the atmosphere, it stays in the atmosphere for more than 10 years. Okay, and basically it harms our ozone layer. Okay, which is gradually basically depleting or harming our layer, that is called the ozone layer, and causing health hazards. Apart from, okay, apart from this chlorofluorocarbon, okay, we have another, okay, gas which is also known as nitric oxide, okay, which is also harming our ozone layer. Okay, you don't find in the book, but it is nitric oxide. Okay, now what is nitric oxide and how it is produced, okay, in the atmosphere? It is produced in the atmosphere by jet fuels. Okay, jet fuels, which okay, whenever we are talking about jet fuels which are emitted by planes and jet fighters, etc., or fighter planes, etc., which is responsible for the harming of ozone layer. Sometimes we find planes and jets basically flying low in the stratosphere. So in order to avoid, okay, avoid weather disturbance or thunderstorm, lightning, etc., they fly low in the stratosphere. When they fly low in the stratosphere, okay, what happens is, okay, They burn fuel. And this exhaust or burnt fuel basically contains nitric oxide, which breaks down the ozone layer. So these aeroplanes basically pollute our atmosphere. So let's take for example, this is the aeroplane which I am drawing here, and this is the aeroplane which I am drawing here, This basically emits smoke. This smoke basically is an exhaust by burning of fuel. This fuel is basically nitric oxide, which eats away our ozone. This layer is also free of water vapor and dust particles. Now, whenever we are talking about water vapor and dust particles, in the previous class, I have told you that carbon dioxide and water vapor is present up to 90 kilometers from the surface of the earth. That means it exists till the initial or the starting boundaries of thermosphere. Now whenever we are talking about thermosphere, it's basically ranges from 80 kilometers to 450 kilometers. And I have written or told you that water vapor is present in this layer, but here it is told in the book that this layer is free of water vapor and dust particles, and this layer provides ideal flying conditions for aircraft. So aircraft basically fly in this layer, that is in the stratosphere, due to the absence of water vapor. But I told you there is a presence of water vapor, which makes this layer free from weather disturbance. So if there is no water vapor, you will not find clouds, you will not find weather disturbance or storms, etc. happening in this layer. But there is water vapor present up to 90 kilometers. And why? Now this layer basically, I told you, absorbs ultraviolet radiation. It absorbs ultraviolet radiation, gamma radiation, X-ray radiation, etc. And it basically warms this layer. When this layer becomes warm, the air molecules spread far apart from each other. Are you understanding? They are not closely packed. So this layer is not so dense that it creates weather disturbance. This is one of the reasons that you find little or no water vapor in this layer. Are you understanding? So you understood that ozone layer basically increases the temperature of this layer. And water vapor is a variable gas. Sometimes it is present, sometimes it is absent here due to the temperature of this layer. There might be less water vapor or more water vapor according to the temperature of this layer. And another reason is it is far from the earth. So gravity plays a vital role, in keeping the molecules together, but you don't find gravity here, so do you find less water vapor here. So due to the absence of water vapor, you find aeroplanes fly in this layer without any problems. This much for today. Thank you for listening. Hope you find this lesson useful.